Okay, let us demonstrate how to use the iperf3 to measure the network throughput between two hosts. Okay, as my second host, I start up iperf3 as a daemon at the server and in the daemon mode. Again, at my first host, I run the iperf3 to my second host. So we try to measure the throughput between my first host and the second host. So it's about 1.8 giga. Okay, may I do it again? So 1.7, 1.8 is about it's about 1.8. Okay, so if your first host have already installed the NTOP monitor tools, okay, the traffic you have done by the iperf3 will also show up here. Let me know it here. Okay, I need to increase the timing here. So you see that we have do the two iper experiment, and it's picked up about 2 gigabit traffic here. Okay, if you monitor the traffic by MRTG graph, then it may need to wait for 5 or 10 minutes, because the MRTG, they take the data in 5 minutes in average, so that we may need to wait for maybe in the second round of data, then we will show up the traffic done by the iper. So after 10 minutes, it will show up the traffic here. But of course, this one is much less than the NTOP measure, because this is on the 5 minutes average. Now let's introduce a tools to measure the level latency of a remote site. I can use the hping to measure the round trip time from my host to the remote site. For example, the UCLA website. It will give me about 7 milliseconds, and we can also measure the MIT. It will give me about 3 milliseconds. How about if I measure the site in Hong Kong, HK UST.Hong Kong? It give me over 200 milliseconds. Okay, we can use traceroute to display the route path from my host to a remote site, so that I can use the traceroute to the UCLA EDU. Okay, it will go through 12 network gateway. Okay, the start here, they mean that the gateway or the router do not send back the ICMP package to the sender, so that it will give you the start information. Otherwise, this router, this gateway, will send an ICMP package back to the sender. Okay, it will go through 12 network gateway, and for example, I go to MIT. It give me 12, also 12. How about the UST Hong Kong? It give me also 12 network hop. But you see that this round trip time, this one is 1 millisecond. From this router to this router, it will give over 200 milliseconds. So from this one to this one, it will go into, because this local host is located in the east coast of the US, so that it need to go through the Pacific Ocean and through the ocean to deliver the message to the destination. Okay, next I want to explain how the traceroute work. Okay, give you a animation here. This is the animation here. Suppose I want a traceroute from this local host to this remote host. Then I issue a traceroute command here. So I want you to pay attention to the TTL. TTL is the time to live package. That time to live value in each level package. Whenever each package have a TTL value, if the level package go through a router, the router will be decrease the TTL by 1. Okay, if the package TTL becomes 0, the router will not forward the level package. Instead, it will send the ICMP package back to the sender so that the TTL is expired. Okay, so now we do this animation here. The TTL is 1, so that it will give me a ICMP package back. Next time it go to 2, so it go through the router become 1, and go to the second router becomes 0. This router will send an ICMP package back to the sender. Okay, now the next round is 3. TTL is 3. Go through the first router become 2. Go through the second routers become 1, and go to the third router becomes 0. So that this router will send an ICMP package back to the sender, telling the sender that your level package TTL is expired. Okay. Now go to the TTL 4. So that the TTL become 3, go through the second router become 2, go to the third router become 1, go to the fourth router it becomes 0. So this router send an ICMP package back to the sender, so that your TTL value is become 0. So I cannot forward your package, so that you will receive an ICMP error message. Now this time the sender set the TTL to be 5. It goes through the first router, become 4, and then it go to the second router, become 3, go to the third router, become 2, go to the fourth router, become 1, because it's non-zero. It finally reach the destination. Now the destination do not send an ICMP package. It will send a large package back to the sender. When the sender received a large package from the destination, then it means that the package finally reached their destination host. This is how it will the traceroute work. Next, we can use the Wireshark to analyze some traceroute package. Okay, so let me see this one. I go into speed down here. Okay, so I go into my second host here. Okay, so for my second host, I want to traceroute a host. Okay, I add some wait times, and then so I want to traceroute to this host. Okay, so first it will go through the network. It will go through the second host gateway and the network gateway, and finally reach the destination. Okay, so at my first host, I want to start up a Wireshark here. Okay, okay, I captures this interface. Okay, I start to the interface, and then I do some filtering. So I filter. So I will filter any package is port active and also ICMP. Then at my second host, I do the, let's see, at my second host, I do the traceroute again. Okay, so when you see that the Wireshark have already picked up the traffic here. So we look at this one. Okay, maybe I need to have not. Okay, yeah. So I apply the filter. So I filtered this package, TCP port 80. That means a web traffic and the ICMP package. So when I look at this package, okay, remember to look at the TTL. The first package. This is from my second host. From my second host to the destination. So the first package is the TTL is equal to 1, and this one is my second host default gateway, and then it will send an ICMP package so that the TTL exceeded. Okay. Now because they will send 3 in a row, so that this one is 1 ICMP package, TTL1 is return the ICMP package. Now this time is go to the TTL equal to 2. Now this is not my default gateway, not the second host default gateway send the ICMP package. Now this is the network gateway, the router send the ICMP package. So this is 2 the ICMP package, 2 the ICMP package. Now this one is 3 here. It will finally reach the destination so that this destination do not send an ICMP package. It will send a acknowledge package back to the sender, so that when the sender received a acknowledge package, then this means that it's already reached the destination. So this is how the traceroute works, and then you can use the Wireshark to examine and study the traceroute network package.